Hello everyone, welcome back to Gate Academy. Welcome to Gate Academy Global channel. Okay, so in this video I'll be starting with logical connectives. Okay, in the past video you have already learned the basics of proposition. What exactly are the propositions? We have learned basic few things like what exactly is proposition, the declarative statement. It must be either true or false, not both at the same time. What is the proposition variable? What are the types of propositions, be it atomic, primitive, or molecular compound? We have seen it. Okay, so now in this video I'll be discussing about our logical connectives. Okay, logical connectives. What are these logical connectives? We'll have a look. Okay, so connectives means connection, like the stuff which is connecting. Okay, and logical means we are connecting the logics. Okay, we are connecting the logics. Okay, clear. So let's say we'll start with the basic. Let's understand each one of these one by one. Okay, so there are basically 5 important connectives which we discuss. Apart from that, there can be other connectives as well. Okay, but those are not of much use, and if that exists, it will be told to you in exam what exactly is that kind of connective. Okay, need not worry. The 5 major connectives and the most important ones we will be discussing: not, and, or, implies, or conditional, I should say, conditional, by implies, or by conditional. These are the 5 major connectives which we will discuss. Okay, let's see one by one each one of these. Let's talk about the not one. Okay, what exactly is the not logical connective, or simply the not logical operator I'm having? Okay, so if there is a proposition, let's say P, if P says Arvind loves mathematics, let's say, Arvind loves mathematics. So how will I be writing the negation? Basically there is an important word for the not, that is negation. What did I say? Negation. Okay, I'll be writing symbolically like this. Symbolically I'll be writing like this, or we can write it like this as well. Okay, or maybe something like this. Okay, you might see such kind of thing. Okay, so this is the most prominent one. Which one? This one. This is the most prominent one. It means not P. Negation of P is not P. Now what will it tell me? Arvind doesn't love mathematics. Doesn't love mathematics. Very simple. Okay, so if I talk about the truth table, that is important. You have heard about it in digital circuits as well. Truth table. Okay, so if I talk about truth table, let's say if this was P, then what will be the negation of P? Let's see. If the value, because P is a proposition, and proposition will be having some value, it will be either true only or false value only. We know that. Okay, so say if the P value was true or false, then what will be the negation of P? If the value of P was true earlier, then the negation of P will become false. And if the value of P was false, then the negation of P will become true. For an example, if Arvind loves mathematics, if this was the proposition and its value was true, if its value was true, okay, if its value was true, then what will be negation of P? Negation of P is Arvind does not love mathematics. So if this was true, this has to be false. If this was true, it has to be false. What has to be false? Arvind doesn't love mathematics. It's false because he loves mathematics. So negation of it will be false. Okay. What about if its value was false? What was it if its value was false? Arvind loves mathematics. It's false. That means Arvind doesn't love mathematics. That means Arvind doesn't love mathematics. That means this is the statement negation. So its value is true. If proposition was false, in that case negation of P will be true for sure. So this was our negation, or simply the not logical operator or connective. Okay. Let's move on to the next one. The AND connective. What? AND. The symbol for this one is this one. Okay, this is the symbol. We write in English, we normally, when we'll be having sentences, we'll be writing or denoting it by AND. Okay, and in the case of negation, we generally either write it like this or something like this. That it is not the case. Before moving to the next one, let me write it also. It is not the case that Arvind loves mathematics. Okay, so this is the stuff. You can write negation of P like this or like this. Both are same thing. Okay. So similarly, if I talk about the AND operator, and in that case, most of the time you will find this. Okay. So let's see how do we use this connective, and what exactly is its truth table, how does it work. Okay, so let's say P is a proposition which says I like to play football. And Q is I love to travel. Okay, so if I do like this, P and Q, what does it mean? I like to play football and love to travel Let's understand its truth table. You have already used it many times, so let's see what will be the value now over here. Okay, if I say this is P, this is Q, and then I'll be talking about P and Q. Okay, let's say if its value was true, false, false. If its value is true, false, true, false, then what will be the value of P and Q? See over here. If I say this statement is correct, I like to play football, and this statement is also correct, that I love to travel. Okay, in that case my P and Q will also be true. If both of them are true, then in that case this will also be true. That means I like to play football and love to travel is true. Okay, important. If I say I like to play football, that is true, but I love to travel is false. This is true, this is false, and I have connected them using logical AND. That means it has to be false. Why? Because only this part is true within the sentence and only this part is false. But I have to understand, for AND operator, both have to be true, or whatever propositions I am talking about, they all have to be true, so that overall my compound proposition becomes true. So that means it is going to be false. Similarly, false over here. If this is false and that is true, again this complete compound proposition value will be false. If I talk about false, false, then it will be definitely false only. P and Q. Okay, this is the point. Exactly in a similar way, I'll be talking about the OR. Okay, the OR logical connective. Okay, we write it like this, the notation or symbol, and in English we'll be writing like this. Okay, this is inclusive OR. This is very important to understand. Inclusive OR. Inclusive OR means both can also be true at the same time. Both can also be true at the same time. Okay. Exclusive means only one has to be true. Okay. Let's see. So, or, okay, let's take the example. If P is the proposition which tells me I will teach maths, Q is I will teach maths or mathematics to be precise. Okay, and the Q is I will go for vacation. Go for vacation. Okay, so what will be my P or Q like? P or Q will be like this. I will teach maths or will go for vacation. I will teach maths or will go for vacation. Okay, I'll teach maths or will go for location. Okay, this is it. Now let's understand when P or Q will be true depending upon the truth values of P and Q. When? Okay, so let's see. P, Q, P or Q. True, false, true, true, false, 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 true. Okay. So let's see P or Q. So you must know this thing. Or means either side it can be true or both can be true. Okay. So that means when P or Q will be true only if P or Q will be false only if both are false. Otherwise it will always be true. P or Q will be false only if both are false, or all the atomic proposition you are using, okay, for creating compound proposition using connective, or if all of them are false, then only your compound proposition will be false, otherwise it will always be true. That means only this part will be false, otherwise in every other scenario the value of P or Q will be true. Okay, whether this is true or both of them are true, in that case it is going to result in truth value. Otherwise what will be happening? If both are false, only in that case the overall compound proposition P or Q will be having value false. That's it. Okay. Or so let's talk about the next one, that is implication. Implication is an important one. Okay, there are numerous questions being asked over this concept, implication. This is very important to understand. Okay, implication, we write it like this. Okay, we also say it implies. What implies? We'll have a look at everything. Okay, or we call it conditional as well. Conditional. Let me write simple sentences to understand, to make you understand. Okay. So something like I will apply for gate 2023 Q. I will appear in gate exam. Okay. So let's see. If I write like this, P implies Q, okay, then what does it mean? It means, see over here, this is very important. If I will apply for gate 2023, then I will appear in gate exam. So over here something like if else, not if else, if then scenario is there. What? If then scenario is present over here. If then, okay, and very important. Okay, so let me just give you the truth table and understand. Let's understand it deeply. Okay, if there is P, if there is Q, and there is P implies Q. So what will be the truth values? Let's understand that. Let's say if this is false, this is false. If this is false, this is true. This is true, this is false. This is true, this is true. Let's see what will be happening. Just remember, only this case will result in false. Only this case. Otherwise, it will always be true. Otherwise, it will always be true. True implies false. If this is the truth value, then the implication will have the false value. Why so? We'll understand this. Just wait for the moment. You can just simply write it and then grasp it. Okay. So let's understand how does it work? How does implication work? How does the conditional stuff over here works? Let me simply tell you, whenever you are having some kind of this scenario, something written like this, it means what? It means P is your hypothesis. You can also call P as your hypothesis or the antecedent and Q is called your conclusion or consequent. Okay, this is important. Conclusion or consequent. Okay, so just understand this properly, understand this carefully. I'm giving you a hypothesis. Okay, I'm giving you a proposition. Okay, hypothesis is like if you work hard, okay, or simply let's take this example only. If I will apply for gate 2023, then I will appear in gate exam. Let's say this. Okay, let's say this. This is the hypothesis that if I do this, then I will do this. If I do this, then I will do this. Okay. Now, when this implication will be true, if I will apply for the gate 2023, then I will appear in gate exam. Okay. If I have not applied for the gate exam, I have not applied. Whether P implies Q will be false or true, just understand. I have given you an hypothesis. I say I will conclude this if this is true. I will say I will conclude this if you follow all the prerequisite. If you will apply, then only I can say okay, you will be able to appear in gate exam if you apply. But the stuff is you have not applied. You didn't fill up the form. Was my prerequisite fulfilled? Why? What was the prerequisite? That first of all I should apply for this. My prerequisite have not been fulfilled. If my prerequisite haven't been fulfilled, how can this scenario be false? This is always true. This is kind of experiment. I propose this hypothesis, this was the prerequisite, okay, and this was the conclusion. If you are not fulfilling the prerequisite, can I expect something? No. If I am saying to do something, I am asking you to do something and you are not doing that, then can you conclude that I was wrong? No, you cannot conclude I was wrong. You can only conclude that I am wrong if I tell you something, if you do this, then this will happen. You can only conclude I am false, I am wrong when you do the prerequisite stuff and you do not get the conclusion. For an example, if I say, if you work hard, then you will get a gate rank. Okay, you didn't do any sort of hard work. You did not do any hard work. Okay, you are simply enjoying the stuff. Okay, enjoying the entertainment, going for the movies, going for the events. You didn't do any hard work. Okay, can you conclude I was wrong? To conclude that I am wrong, first of all, you have to fulfill the prerequisite. What was that? That you have to work hard. And if you work hard and you could not get through the gate, then you could say, sir, you were telling me if I'll work hard, I'll get through the gate. But I worked hard, I didn't get through the gate. That means you are wrong. So P implies Q. This is the prerequisite. This is the conclusion. When this whole experiment will be false, if you completed the prerequisite and you did not get the desired result. If this was true and this was false, only then in that case this will be false. True, false is false. But if I say P is false, you didn't fill up the what? You didn't fill up the prerequisite. I told you to keep the temperature for some experiment 273 Kelvin. Take the pressure at this ATM. Okay, and then take the pressure, temperature, and whatever. So many stuffs are there. Volume of the gas like this much. Okay, you didn't follow any of these things. Will that conclude that whatever I was suggesting, whatever I was telling you, whatever I was whatever hypothesis I was giving you, will that be giving me a proper conclusion? No, because I haven't started right. If I start right and I am not getting the conclusion right, then only you can say, sir, you are wrong. But if you are not starting right, how can you say that I am wrong? No. In that case, it will always be right. That means if P is false, irrespective of the fact whether Q is false or true, if you are not fulfilling the prerequisite stuff, implication will always be true. Implication will always be true. Okay, we need to understand this. Okay, so if this is clear up to this point, now I would like to give you another expression for implication. Okay, what exactly is the other expression we are having? Okay, so I hope you can relate to these kind of stuff as you have discussed in digital logic. Okay, there is a NOT operator, there is an AND operator, there is a OR operator, there is a implication. No, there is no implication, but you can conclude from the truth table what will be the expression for the implication. Okay, so if you remember in your digital logic, your dot operator is there, which is like AND over here. There is a plus operator, which is like a OR operator over here. There is a bar or like this comma, like A bar you can say, or A dash like this, which means negation of A over here. Okay, so if you have this kind of expression, always remember, corresponding to any proposition expression you are having, mathematical logic expression you are having, there can always be some digital expression, digital Boolean expression, there can be there. Okay, for each proposition expression you are having, there can be some what? Digital Boolean expression. Just remember that. So on the basis of this, can't you say, just solve using the what? K map, this one. Okay, what you will get? Just take true as 1 and false as 0. Just take that up. You will get that this will be false only in what case? This will be false in only this case. Let me simply write the direct expression for this. P bar plus Q. This will always be true. This will always be true. Okay, this will always be true. P bar plus Q. Let's see. If P is false, it will always return true. It will always return true. If P is true, then Q has to be true. If P is true, then Q has to be true for this complete expression to be true. We know that. If P is true, then it has to be true for this to be true. If P is false, then by default it is true. But if P is true and Q is false, its value will be false. So just remember, as in you have this digital logic expression, similar to this we have a proposition expression, negation of P, this is for or Q. So this is the another expression for P implies Q, which you should remember. Okay, it also means negation of P or Q. You must remember this. Okay, negation of first or Q. Second one as it is, negation of first, and in between there will be or. So you have to understand. Okay, we'll understand its English translations as well. We'll be taking up a number of examples. First of all, we'll finish only the logical connectives over here. Okay, that as a logical connective, what role does it play? Later on we'll be discussing it in detail. Okay, so let's move on to the next one and the last one, that is biconditional. Biconditional or by implication. Biconditional or by implication. What is the symbol for this one? This is the symbol. Okay, and we also say for this one, okay, English translation we'll see this later on. Okay, we'll say by implies. What we'll say? We'll say by implies. We'll say simply this one. Okay, see this. P says I am studying. I am studying. And Q means I am not playing outside. And if I write P by implies Q, what does it mean? It means I am studying by implies I am not playing outside, or simply there is a English we will be using some phrases or some set of words we will be using to denote the conditionals and biconditional separately. Okay, so let me firstly introduce over here for the biconditional, that is if and only if and only if. In short, it can be written like this, IFF. In short, it can be written like this. Okay, I am studying if and only if I am not playing cricket. I am not playing cricket. I am not playing cricket. What does it mean? Let's see. Playing outside, sorry. Playing outside. Let's say this. Okay. So let's have a look at this one. This P, Q and P by implies Q. True, 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 false, false, true, false, false. It will be true only when either both together are true or both together are false. It will be true only if both together are true or both together are false. We need to understand this. Why so? By implies means that one statement is telling me that if this is the case, then this is definitely going to be there, and if this is the case, this also has to be there. Okay, by implies means both ways there is an implication. If this is true, then this has to be true. If this is true, this has to be true. By implication, both sided implication. Okay, see over here, if I am not studying, then it means I am not playing outside. Also, if I am not playing outside, that means I am studying. If one is true, second one is also true, then I will say yes, this is correct, this is correct, this statement is correct. If I am studying, this is also true, and this is also true, that this means this statement is true. If I say this statement is true but this is false, true false, what does it mean? I am studying and this statement is false, I am not playing cricket, it is false, I am not playing outside, this is false, that means I am playing outside, I am studying. How can this be true? How can this be true? That is, this is not implying this one. If I am studying, how can I play cricket or play outside? This is false. So false. If this is false, this is true. I am not studying. I am not playing outside. This is true and this is false. I am not studying and I am not playing also. That is wrong because this was told to me. I am studying if and only if I am not playing outside. That means if studying, not playing outside. If not playing, that means studying. So this is again wrong. And if I say I am not studying, this is also false. And if I say I am not playing outside, this is also false. What does it mean? I am not studying. That means I am not studying. Simple. I am not playing outside. It is false. That means I am playing outside. I am playing and I am not studying. That means same. So this is again true. Okay. So you can also write it as if and only if, IFF. Okay. So this was the point. How does this thing work? Okay. By implication. If I talk about the expression for this one, other expression in the basic operators, in terms of basic operators. So P by implies Q can also be written like this. Okay. It can also be written like this. P implies Q. This as well as and this also must be true, and Q implies P, this also must be true, so that I can say P by implies Q. Otherwise I won't be able to say that okay, this thing hold true. I won't be able to declare this, I won't be able to tell this one. Okay. So this was it with respect to biconditional or by implication. We have seen what exactly are the different logical connectives, we have seen the symbols for them, we have seen the examples for them, we have seen the truth tables for them, we have seen the alternative expression if those exist. Okay. So in the next video I'll be taking, I'll be discussing the conditional, or rather I should say simply the implication a bit further. I'll be talking about some related terms which are related to this implication. We'll be discussing that in the next video. Okay. So in this video it was till this point only the logical connectives we have seen. Okay. After covering the implication in detail and after covering some English translation, we'll be solving a numerous problems. Okay. We'll be studying what exactly is a tautology, contingency, satisfiability. We'll be having a look at all of these stuff. Okay. So thank you guys for watching this video. I hope you have understood, you have got a better insight, you have got some better clarity than you had before. Thanks for watching this video. Let's meet in the next video. Thank you.